This week on Quality Digest Live, we'll discover that scientists may need to brush up on their Deming.
Plus, why the best idea doesn't always win. That and more when we come back. Welcome back to Quality Digest Live for October 17th, 2014. QDL is your weekly look at who and what is making the news in the world of quality. I'm Dirk Ducharme, Editor-in-Chief of Quality Digest.
Yes, he is, and I'm Quality Digest publisher Mike Richmond. Look, up in the sky. It's a bird. It's a plane. It's an Ampere.
An Ampere?
Really? Well, I guess so. Well, believe it or not, the hottest new superheroes in the galaxy come not from Marvel or DC Comics, but from, of all places, NIST.
Those are fun-loving guys.
Imagine that. That's right. The National Institute of Standards and Technology recently announced the League of SI superheroes, who use their incredible powers of measurement to perform amazing feats of science and engineering. The League of SI superheroes came together to celebrate Metric Week earlier in October. So who, you may ask, you're asking this, Dirk, who exactly is in the league?
Well, I want to know, man.
You've got Meter Man. You've got
Meter Man.
Professor Second. Monsieur Kilogram,
Monsieur Kilogram,
Dr. Kelvin, and of course the aforementioned electrically attractive Ms. Ampere. Their stated mission is to make sure that all the measurements that interweave our lives are as accurate and precise as possible. Now, as you might guess, I know I guessed that, the League is intended to expose young students to science, technology, engineering, and math, and supercharge STEM education activities across the country. This is a major issue confronting the future of manufacturing here in the United States, the lack of young people coming into the industry. It's one we've talked about certainly a lot on this show and in Quality Digest Daily. It's hoped that making STEM education more interesting to kids, especially at the grade school level, will lead to more people pursuing careers in the field in the future. So, we think about this, and we often think about it from the perspective of universities, grade schools, and then ultimately leading to universities, that we need more university programs. But really it comes down to vocational and trade schools too. We know that not every kid who might want to get into manufacturing or pursue STEM education is going to necessarily go to university. They may want opportunities in vocational and trade schools, right?
Yeah. Sorry, one thing just occurred to me though, is like you've got Meter Man and Monsieur Kilogram.
Yes. Yes.
We don't even use those in the States.
Well, yeah, but that's okay.
On the industrial level we do, but for students it's like, what's a meter?
Well, maybe they'll learn, Dirk. Maybe that's the point of this whole thing.
Inchman.
I knew that guy, but no.
Mr. Pound.
It's interesting because what you're talking about is actually a flaw in the educational system. Exactly, and this is going to address that, I would hope, right? Kids maybe don't know what a kilogram is, so find out from Monsieur Kilogram what a kilogram is. And educational institutions, Dirk, in all seriousness, I know you're being serious, kind of. In all seriousness, educational institutions can't do it alone. Organizations such as NIST need to step up, and they are, by doing programs like this. And industry needs to step up too. We've seen some of it in our travels around the country and visiting different schools and different manufacturing organizations, that some manufacturers are helping educational institutions. Some of our customers and our clients that we work with, our partners, are providing tools and equipment to educational institutions so that students have cutting-edge technology to work with, so that when they do go through these programs, they come out on the other end and they already kind of are ready to measure and ready to test and ready to work in the fields that.
And in this case, at least they're familiar with what the SI units are and so forth.
Exactly,
even if they're not using them every day.
Well, NIST has released, to help with that, NIST has released a cute little video introducing this League of SI superheroes titled Desperate Measures. It's worth a look, and you can check it out embedded. The video is embedded in the story link just below this video player screen. Of course, as always, all the stories that Dirk and I are going to be covering on today's show are available again right down there.
And you actually should go out and watch that video. It's cute. It's kind of cheesy, but it's cheesy in kind of this endearing way.
Kids will like it, even kids that are Dirk's age.
Will
like it.
There you go. Okay, well, speaking of science, science should discover Deming. That's the title of an article from Quality Digest frequent columnist Matthew Barcelou. He is referring to W. Edward Deming's point 11A out of his famous 14 points, which reads, eliminate work standards or quotas on the factory floor, substitute leadership. Barslu points out that most of us, hopefully in manufacturing and service, understand the inherent problem with quotas. They can lead a person to aim to fill the to fill the quantity of the quota without really caring about the quality of the product or service delivered. They got to meet a number, a certain number of calls in a call center, or a certain number of pallets delivered by a forklift driver within a shift. But another problem, as most of us know, and as Barslu pointed out in an earlier column, is that quotas also tend to be kind of one size fits all, and don't take into account variables which may be beyond the quota filler's control. So basically, when you have a quota, it's based on an average time. Even if they're done properly, they're based on kind of an average time with maybe a little buffer that it takes to get a job done. So therefore, you should be able to do X amount of these things within a certain amount of time. But what it doesn't take into account is if there is some sort of change further upstream in the system, then that all goes out the door, because now all of a sudden what was enough time maybe isn't enough time anymore. And yet you still have this quota in place, and so now you've got these people that are either not making their quotas and being penalized for it, or they are just doing what they can to fill the quota and just get it out the door. We don't care. We got to make our numbers. Got to make our numbers, right? Okay. So all of us understand this. All of us who work in industry understand this. But apparently, according to Barslu, academia didn't get the memo. And he's referring to an article in the magazine Current Biology and another in the UK medical journal, The Lancet. That is the premier medical journal. The Lancet, and the quantity and quality of a scientist's research is now being measured. By quantity, we mean the number of papers published, and by quality, the number of citations a paper gets. So scientists who don't meet these really kind of rather arbitrary metrics of their work could actually, in fact, lose their job. And one can see what road this actually might lead you down. Summarizing from the Current Biology magazine article, Barslu points out that since the measures of scientists' research are used to decide promotions and positions and the funding needed to perform research, this may lead scientists to just concentrate on the low-hanging fruit, concentrate more on publishing and the quantity of publishing than on science, which is actually their job, right? So Barslu writes, quotes, "A scientist that neglects to meet the quota due to concentrating on solving one difficult yet important problem may not be doing research for long due to failing publishing enough trivial research to keep her numbers up." And in fact, in a really scathing 2012 editorial in The Lancet, authors John F. Allen and Fanis Miserly bring to light that several noted scientists at that time at the prestigious UK universities, Queen Mary University and Barts, were headed for termination, the chop, as they say, for what some say are really untested and irrelevant metrics to judge the performance of their colleagues. And actually we have a slide here that has their quote. Allen and Miserly write, quote, "Our school has a reputation envied worldwide for research by individuals now for the chop. Their respective crimes committed between 2008 and 2011 include too few publications as a significant author in a high-impact journal and below-average external funding. In other words, imply the authors, we don't care about the significance of the research you're doing. We only care about how many papers you have been published in and how often you have been cited." Well, as Barslu points out, the university's management will probably get what they want in the form of increased funding and an increased number of publications. But along with that, they can expect a number of significant discoveries, the number of significant discoveries to go down. Again, got to meet the numbers. So it's much easier to kind of do trivial research, quick and easy, get it out the door so we can publish. And the really important stuff, well, maybe that gets backburnered. Another thing to expect, and what has already happened, was contributed in this comment from a reader that was sent in response to Barslu's article, and I think we have a slide for this one too. This is from the reader. This is related to the overall increase in distrust that we see throughout society. The fundamental belief that a researcher researches out of curiosity and for the intellectual pleasure of discovering and understanding things has long gone. The starting point now seems to be that by definition, researchers are lazy bums living off taxpayers' money that need to be pushed to do some actual productive work, like publishing, preferably a lot. Then we see that he or she has worked hard. He or she has worked hard. How sad. And that comment came from Willy Vanderbrandt. So again, it's this idea that even the idea of quotas, which we used to see, and we still see to a certain extent, within manufacturing and service, and we still see, particularly call centers, they suffer from that a lot, I think, that this really reaches into areas where it's hampering kind of basic research, things that are important, because again, we've got this idea you've got to meet a quota of, the publish or perish thing. I mean, that quote has been around for a long time, but it's still true even in today's society, when we know that the idea of quotas is just a bad idea. But somewhere along the line, kind of in the staid ivory towers, it's still something that's going on.
Yeah, I think it actually is worse today because the internet and the hyperlinking and this stuff makes it worse. And the idea,
that's a good point.
Yeah, the idea that you're gonna want to be referenced by others who are working and this idea that research always rests on the shoulders of others is good. I mean, it's an underpinning of what research and science and learning is all about. But it can also be a problem in a case like this where maybe there does get some laziness creeps in there. You're like, well, somebody else already did this work. I'll just cite it, come up with some maybe new spin on it, throw it out the door, as opposed to really doing the hard work, and maybe that takes years, to really learn something and uncover something that's of real value to science.
Yeah, primary research takes a long time.
Long time.
and so meanwhile, you're getting pressured to
crank up
papers and fundraise and everything else. So.
It's definitely counterintuitive. I think as you say, I think manufacturing industries learn better. Right. Maybe some of the softer skills in the educational environments maybe still have a little bit of learning to do. And as Barcelo suggests, read Deming.
Read Deming.
Substitute leadership.
That's right.
Good stuff. Okay, thanks, Derek. All right, well, also in today's business environment, it's not enough to do what you've been doing just as you've always done it before. In many cases, it's not even good enough to make incremental improvements. Today, organizations want breakthroughs. So the topic of innovation is on everyone's mind. I mean, we talk about it all the time, innovation. People want innovation. People are trying to learn how to innovate better because, just improving a little bit at a time, doesn't always cut the mustard, right?
Right.
The topic certainly resonates with best-selling business author Scott Berkun. And Scott Berkun specializes in the regions of thought and theory where management and creativity intersect. A recent posting on his blog is titled "Why the Best Idea Doesn't Always Win," which is adapted from his book, The Myths of Innovation. This reprinted article appeared in Wednesday's issue of Quality Digest Daily. So you may ask, what would cause the most creative, the most logical, and the most efficient ideas to sometimes wither and die on the vine? And the corollary, why are bad ideas, once they're established, so difficult to dislodge? Well, Berkun offers up a number of historical and cultural examples. Things like the QWERTY keyboard, the Philips screwdriver, and JavaScript continue to dominate their respective industries and sectors despite their inherent and well-documented inefficiencies. We've all heard about this, right? I mean, there are not necessarily, these aren't necessarily the best solutions to the problems that are presented.
Right.
But yet they are the ones that we kind of are stuck with and become ubiquitous all throughout industry or protocol. So it's like, why, right?
Yeah.
Well, to answer that question of why, Berkun offers up 7 underlying reasons, what he calls the secondary factors of innovation. I want to show them here on a slide so you can kind of all see them. The first one is culture. Second, dominant design. Third, inheritance and tradition. Fourth, politics, or in other words, who benefits from that. Fifth is economics, and sixth is the subjectivity of goodness. And finally, 7, short-term versus long-term thinking. All those are valid reasons why innovations don't push out other products or other things that are already there. All these are worth considering, and I certainly strongly recommend reading Berkun's blog, if not his book itself, to delve in more deeply on these issues and the factors affecting the adoption of innovative ideas. However, the one factor that I want to take a minute or two to discuss is something that I found especially interesting, and it's point 2 on dominant design. And I think this to me is kind of the crux of the whole thing is why. Right. Why these things are so difficult to dislodge. And it's here that Berkun chats about the QWERTY keyboard, which was built into the typewriter design more than a century ago. I believe it was designed in 1867, if my memory serves, and it was designed that way for a simple and very important reason. It helped avoid jammed keys.
Okay.
That particular alignment of keys was the best one after some research and after some trial and error that jammed the keys the least amount of times. Okay, now that was an important factor in the 19th century, no doubt.
Right.
In the 21st century, not so much, I think. And as Birkin writes, the designers of early computers wanted to ease people into their invention and make it as approachable as possible. So they stuck with the QWERTY keyboard,
Yeah,
even though
even
though it's clearly less efficient than other placements of keys. They say, well, we want people to be comfortable with this thing, this computer. It could really seem weird to people, but we want to make them comfortable with it with word processors and computers, so we're going to keep the QWERTY keyboard.
Yeah, and if I remember
Easy
right, the QWERTY keyboard, if you look at least within the English language, tends to favor one hand over the other, I believe. The left hand does more work than the right hand, or something like that.
Right,
yeah.
but again, it was built that way because of jammed keys. And it happens all the time. Something new is built along the lines of something old. Hey, think about it. Think about the car. I mean, where's the word car come from? It comes from carriage, right? I mean, it's like, carriage and horse and carriage.
Yeah.
And, it's like not a technology we have anymore, but the form of a car, the name of a car came from carriage, right? I mean, it makes sense. So basically, something old is built along the lines of something else, and if the basic design of the new thing is too radically different, it better be way better than the original to justify the cost and effort to learn the new way of doing things. I mean, if something is clearly better, if it's a breakthrough that people can easily understand and use, it's going to hit. But if it's something that takes a little bit more effort, it better be so much better than the other one. In the case of the QWERTY keyboard, it kind of wasn't. So we're kind of stuck with this QWERTY keyboard now until somebody maybe proves that it's easier to do in a different way, right? And I think it's for that reason that incrementalism many times proves to be the enemy of breakthrough innovation. It's just the way the human mind works. I mean, it works, again, that you do what you're comfortable with, you make small changes, and you don't want to be threatened. People don't really like change. I mean, psychologically, people don't like change. And if you're going to have something that's going to be very, very, very different, it better, again, have the value for people to invest in doing that. Right. And again, it's just the way the human mind works. Now, speaking of minds, Scott Birkin, I think, has a first-rate one. And this article, it's really a fun read. I mean, it was interesting to me. I had not actually been familiar with Birkin's work, so I am going to take the time to check out some of his books. I recommend that you do that as well. I think that you probably won't be disappointed to read his stuff. He's clearly a really interesting thinker. He's got what I love, which is a really good historical perspective on the way things are and the way things came to be. And talk about innovation, which is really his bailiwick, is management, innovation, creativity. That's what he covers, and that's what we all kind of need to be thinking about in all of our jobs.
Well, there's another. I think it's one of his points up there. Maybe it's politics or something else. Is sometimes, and a good example is Beta versus VHS. Beta was the better technology, but it was kind of like, well, who had the most oomph out there in the marketplace to really push forward on getting a standard created, and whoever that was, that company won, right? And so then VH1 became the standard for videotape. If you remember videotape. Even though Beta was, even at the time, people knew Beta was technologically, Beta was delivered a better picture. It was the way to go.
But why are we still not using videotapes? Because DVDs, CDs, and eventually now just streaming from the internet became so easy. It wasn't a problem for people to learn how to do that. So that replaced other technology because it was easier. I mean, think about politics, Westinghouse versus Edison 150 years ago. I mean,
right.
Versus DC
AC
current.
versus DC current.
I mean, the entrenched interest, you're right, is also a big part of it. All those 7 points in his list are really fascinating. He gives little tiny bits of pieces of it, but read his stuff, read the book, and I think you'll be interested in finding out about that.
That's right.
All right. Well, now, we're going to move on because we have one final segment for you today, and it's really a good one. And this is something we like to do where we have Tech Corners with a guest in the office with us here in the studio. Dirk is now making his way over to our Tech Corner set, where he's going to be joined by Jeff Cope, CEO of InspectionXpert, and together, the two of them are going to look at InspectionXpert on demand for CAD. So take it away, guys.
Okay, thanks, Mike. And as he said, I'm here with Jeff Cope of InspectionXpert. Jeff, thanks for joining us. So
thanks for having me, Dirk.
This is really a productivity tool, I guess, for people who are creating inspection instructions. Is that?
Absolutely. It's a productivity tool that enables quality planners to create quality inspection plans and inspection documents for doing inspections to make sure that the products that have been manufactured to specification.
And this might be, the person who might use this software would be what, an engineer or a quality manager or something to give instructions for their inspectors, that sort of thing?
Sure, great question. So depending on the size of the company, it could be used, if it's a small company, it could be the inspector. If it's a larger company, they may have dedicated quality engineers or even quality planners for really large companies, people who do nothing but create the quality checklist for the inspectors and operators.
Okay. Why don't you show us how it works?
Absolutely. So InspectionXpert On Demand for CAD is a smart client, so it's launched from the web. It runs on your local machine, but it does so without requiring any sort of installation whatsoever by IT, which means any user within your company at any time from any machine can generate a quality inspection program right away.
Okay. And you're saying this is connected to the cloud or over the internet or what?
Right. So it's launched from the web, but it runs on the local user's machine. So you've got historically you've had thick client and thin client. Thick client would be something that would run on the user's local machine and install on the user's local machine, but it required the administrator support. The thin client would be something that runs on the cloud and processed on the server using cloud resources. What we have is a smart client, which is really the best of both. So you have the minimal overhead of the thin client, but you're able to access the local machine's CPU and resources,
okay.
So you get the best of both.
Okay.
All right, so what I have here is a 3D model generated from CATIA.
Okay.
CATIA is a very common 3D CAD application used in aerospace, automotive, and many other industries. Boeing is starting to send out 3D models to their suppliers. It's very common. So this is, like I said, 3D model from CATIA. We support other CAD formats, CATIA 2D, AutoCAD 2D, as well as we have plans to support a Pro Engineer and NX and many other formats in the near future. But basically, I have a series of dimensions and tolerances on the model, notes, material and process specifications, things that have to be paid close attention to by the machinist making the product, but also need to be paid close attention to by the inspectors to make sure that they got everything. And so what I'm going to do here is I'm just going to click on this and tell InspectionXpert to extract all of the annotations. And now I'm going to export this to a quality inspection checklist. I'm going to choose an AS9102 checklist, which is a very common for aerospace.
Actually, before you do
Sure.
that, quick question. So you brought in this CAD drawing, you clicked one button, and it automatically recognized what were specifications on the drawing.
That's right. The expected values, the nominals.
Okay, the nominals. Okay.
That's right. And so all of the expected values are put into this this form, in this case the aerospace AS9102 form. So the expected value, like the nominal value, plus the allowable tolerance range, because if a dimension is supposed to be, I'll try to stick with SI units here, 25 millimeters, usually there's a tolerance range, so +5 or -5, so which means anywhere between 20 millimeters and 30 millimeters is acceptable, even though the nominal is 25. So our software not only captures the nominal, but also all the allowable tolerances, and does all these calculations automatically, or automagically as we say in software, so that the inspector doesn't have to do that. So it not only does it save time, but it reduces errors. And this particular drawing, or actually 3D model, had 171 inspection characteristics. So it's 171 things that the quality planner would have to go through and verify one at a time to make sure that they got them all in their checklist. And for a 3D model like this with 171 characteristics, that would typically take someone using a manual process all day.
Right.
It'd be an 8-hour process, and I think it took me, even with lots of talking, 4 minutes.
right, exactly.
In a room by myself in a cubicle, probably 2 minutes.
Right.
And I can also generate a 3D PDF file with all of the 3D geometry and annotations. And the benefit of this is those 3D CAD models that are sent out by the large OEMs for inspection, they all require the expensive CAD licenses.
Sure.
Some of the CAD licenses are as much as $10,000 a user just to be able to open up and read a model like this with the PMI, the product manufacturing information.
Right.
You have to train, the companies have to train the quality people on how to use the CAD system to be able to open a model and balloon the print and extract the characteristics. So with our software, the only things in there are things that a quality planner would care about. They open the 3D model and then they generate a 3D PDF, which can be viewed and opened on pretty much any machine. I challenge you to find a computer without Adobe Acrobat in this day and age.
Now, suppose you have kind of a low-tech company or a low-tech vendor, and they want to work from paper. I mean, can you export this as just a regular, some of the dimensions is a 2D, like just a regular PDF file and print it out or that sort of thing? I mean,
absolutely.
Okay.
For the Luddites, we have no, I'm sorry, that's pejorative. For people who want to work from paper, we have...
That's Mr. Luddite.
Mr. Luddite, yeah. Is there an IS character for that?
Yeah, Mr. Luddite, yeah.
Mr. Luddite, that would be me, yeah. So if I click the button here, I can also export a 2D PDF. Which has all of the same capture information, and and it's all in there, so you can print it up and have a paper copy on your desktop.
Okay. Now, does this collect if it's on the CAD drawing, GD&T data as well?
Absolutely. So if you see here, the GD&Ts are captured right in the and exported to Excel as well. So we have parallelism, true position, and even we do some intelligent processing. So for surface profile of the surface, for instance, the tolerance might be 10,000ths of an inch. I'm going to be bad and use imperial units.
Right.
But that would mean the tolerances would be 5,000ths into the surface and 5,000ths out of the surface. So we would actually calculate that. So some of the GD&T knowledge that might be required by someone creating this plan is no longer necessary.
It's going to create. It's going to tell them exactly what they need.
That's right. The intelligence is in the application now.
Okay. All right. And going back to the CAD drawing. So can you annotate? Can you annotate this at all? Besides, I see these are numbered, but could you write little text notes for the inspector, that sort of thing? Useful stuff for them.
Absolutely. I can add notes. I can add dimensions. If you have a limited dimension drawing, I can add dimensions myself, notes, instructions, things like that as well. And I can import my CMM results. A very common use case is a company, so the quality planner does the quality plan. They balloon the print because they have to do this. The FAA requires it. In medical device, lots of different industries require this uniquely identifying of all the characteristics and then generating the report. But then the actual inspection is oftentimes done on a CMM because it can, they can inspect down to the micron and quickly. And so now they have a problem where the dimensions on the print are numbered one way, but the CMM report is outputting the dimensions in a totally different order.
Okay.
Our software can marry the two and basically give you a perfectly formatted inspection report with all the CMM results numbered and presented in the format that's required by whatever the governing standard body is.
Okay, all right, got it.
Does that make sense?
Yeah.
Okay.
So you're saying, so kind of in a nutshell, you bring in a CAD drawing. Does it have to be a CAD drawing? Can you bring in just a PDF or a scan and annotate it? I obviously would do the extraction.
Absolutely.
Okay.
Yeah. So for instance, I'm glad you asked that. So we have what's called optical character recognition.
Oh, okay. So you can read just a scan. Okay.
So right here, if I wanted to, let me delete this one. So not only can we read the scan, but we can go in and basically extract based on OCR or optical character recognition. So that's basically a picture of a note.
And you can still, using optical character recognition, you can still pick up the characteristics. I'm assuming if it doesn't read them right, you can edit it and
that's right.
That sort of thing. Okay, yeah.
Yeah, we try to minimize that.
Yeah.
But worst case, if you have maybe a hand-drawn
Well,
print,
yeah.
some people still have
or a poor scan of if it would
poor
happen to be a
scan,
scanned drawing.
right.
Exactly.
faxed
Okay.
at 100 DPI or something like that,
exactly,
and they
right.
ate their breakfast on it. Yeah.
Okay, so what we have here is you bring in your drawing, electronic or scanned drawing, some electronically. It automatically creates all of the a table with all the dimensions that you need, the nominal dimensions that you need to measure to, and plus or minus, and everything else, all the GD&T data translated into actual dimensions that people need to know. And then you would give that document either electronically or via paper to the inspector.
Absolutely.
And then whether it's being done CMM or operator with a micrometer, you can fill out an inspection report and bring it back in, and then InspectionXpert will compare the two.
Sure, I'll show you.
Okay.
So, for instance, if I want to bring in a CMM file, I can import a CMM file. This one's from PC Demas,
Okay.
but it could be from just about any CMM, Calypso or MeasureMax, GeoMeasure. Verisurf is a one that we see a lot of.
Sure.
If I click yes here, and it brings in all the results, and it automatically highlights in green or yellow or red things that are in tolerance, things that are out of tolerance, things that are marginally within tolerance.
Okay.
So they're in tolerance, but they're close. And it's an intelligent matching algorithm that does that. If there's something that doesn't get matched up, I can go and match that manually. And it remembers it for next time, so that, ostensibly I'm going to be importing from that same CMM every time. And so we'll save the mapping, so you never have to go through that process again.
Right.
It's just instant.
Okay. So we're talking basically the value of this software really is productivity, rather than somebody having to manually go through, extract the dimensions, create the table, so forth. The software is doing that for them in really just a matter of seconds.
It's productivity, but it's also standardization.
Okay.
So
For the forms, for the output.
absolutely.
Okay.
Imagine that you're an aerospace OEM, and you've got 5,000 suppliers, and for every part you may source that to 10 suppliers, right? If you use our software, you can basically create your inspection report such that all of those 10 suppliers are reporting the same values against the same dimensions. So now you can compare supplier A versus B versus C,
Okay.
and who's doing a better job.
And you mentioned AS 9102. What other standard, let's say, industry forms do you guys support?
Sure. So just within aerospace, for instance, in Europe, there's EN 9102, in Asia, SJAC 9102. We support PPAP, a lot of automotive companies, and actually PPAP is making the jump into aerospace and medical device and oil and gas and many other industries. So we support the standard PPAP forms. Medical device with the ISO 1345, and we have numerous oil and gas customers that are, but a lot of them are using the PPAP as well.
Okay.
And one other thing, since you just made me realize, so our software is localized in 14 languages.
Okay.
So Japanese, French, Polish,
Oh, another thing I just thought of.
Italian.
I thought of it when you were talking. So this is on the internet. So what about security? I mean, this is critical company information. We're talking dimensions on products and CAD drawings. How is this protected? How are people going to be secure?
Sure, that's a great question. I'm glad you asked. So basically, the application, although it's launched from the web for ease of use purposes, your data never leaves your computer. So your inspection plans, your inspection reports, the CAD drawings, they never leave your computer. Nothing is sent back over the web. The only thing basically is that the application comes down from the web to the application follows the user from machine to machine, but the data stays on the local machine.
Okay, great. Well, Jeff Cope, thanks a lot.
Thanks for having me.
InspectionXpert was the product?
Correct.
Okay,
InspectionXpert on demand for CAD.
Okay, thanks. Back to you, Mike.
Well, there you have it. Dirk Ducharme, our own Dirk Ducharme, joined by Jeff Cope, CEO of InspectionXpert, and together again they looked at InspectionXpert on demand for CAD. Really good tech corner. We always like it when we have a guest come into the show to join us and be able to do a tech corner here in our studio. It's always fun to do that. So Dirk, nice job.
Hey, thanks.
With
No,
that tech corner.
this is interesting. I mean, what we're seeing a lot more of. in software, and some strictly software tools, also software that work with hardware. It's just a lot more oriented towards what do you call it? Productivity. Is how can we take these jobs that have been, either pencil and paper jobs, or even if done on a computer, still required a lot of keystrokes. Let's say. I mean, I think Jeff mentioned, the drawing we looked at might have taken him all day if he had to do it manually, open up the CAD, extract the stuff, put it into a spreadsheet, so on and so forth. And the idea of being able to do that immediately, and if I believe, if I was right, you didn't have to take all of the dimensions. I think that was right, Jeff, right? Is you could select which dimensions you wanted. So you wouldn't necessarily have to extract your entire drawing, have all, 120 dimensions. Maybe for what you're doing, you only maybe have half a dozen dimensions or 20 dimensions that are critical at that particular juncture. Well, you could just select those, and again, it's just within a few seconds you're creating your inspection report for your folks. So
great stuff.
Yes, good stuff.
Good stuff. Well, thank you, Jeff Cope again of InspectionXpert for joining us in the studio. Thank you all for joining us today on Quality Digest Live. We'll be back at you on Monday with another full week of QDD, Quality Digest Daily, and of course we'll be back next week with Quality Digest Live here on
And
Friday.
next week you don't want to miss, because next week is 25 Minutes with Robert Fangmeyer, the director of the Baldrige program. We did an extended, are going to do, an extended interview with Bob Fangmeyer. So you don't want to miss that. That's going to be an interesting show. We're going to ask him a lot of questions about what's been going on with the Baldrige, how defunding has worked for them, what's coming up for the Baldrige. So be sure to tune in next week.
A lot of good stuff. So check that out next Friday. And again, have a great weekend. We'll see you next week.
So long.
Bye.